Now, we will try to understand some basics. And before we go to innovations and all those research areas, all those areas, it is very necessary that we understand some basics, because all of my friends, all of my participants, they may not be very well conversant with this wind technology and technology. Now, this figure is very interesting, what you are saying. At the ground level, kinetic energy or wind speed is 0, and it rises as we go up in the air. Another is if there are adjacent tall buildings and or mountains or something like that, then wind gets interrupted. There is obstructions, and you will see in the first figure that it is rising a bit slowly. To reach 20 meters per second per hour, we have to go to the height of more than 1500 meters. Second case, there are some trees and houses in the adjacent areas. It is increasing more rapidly, and at a height of around 1200 feet, we are getting 20 miles per hour. And third case may be ocean or water or free area, no interruptions. All the sites are free. Then only after say some 700, 800 feet, we get the same speed, wind speed. Now we will discuss about some of the important characteristics related to us. There is one specialty in the wind and to some extent solar also. These two sources are variable in nature. All the time they will be varying. So wind resource assessment is the very first requirement. We have to start with that. How to assess it? All the time it is varying. So what is the way out? Way out is that it is strongly recommended that one should carry out the measurements for a period of 3 years, but in no case less than 1 year. You have to take the measurement. Which measurement? If you take something, measure something now, and after 10 minutes, it may vary. So that's why we go for the average. So what is the international practice and national practice? That these measurements are taken at the interval of 10 minutes. But manually it is not possible. So these measurements are automatically recorded. Here you are seeing the wind mast. And at different heights you are also seeing the instruments are installed. Anemometer, you are able to see cup type of, it measures the wind speed. And another instrument is there at the bottom. It measures the direction of the wind. So these two parameters are very, very important. On the basis of all these measurements, what is done? A plot like this is made, and this is called wind rose. From the wind rose, you can see that in most of the part of this thing, which is the most predominant direction of flow of the wind. And on that basis, the spacing between the turbine units is decided. In the direction of predominant wind direction, what is the spacing? Normally in India, it is 7D. 7D means 7 times the diameter of the wind turbine rotor. And perpendicular to that predominant wind direction, what is the spacing? That is 5D. So that's why it is called 5D, 7D spacing. Why this spacing is required? Because when you have extracted the energy from the wind, then it will recoup. But after traveling some distance, after taking some time, it will regain the energy and then it will be available to meet the next turbine and so on. Now it is again very this important and very good slide. I'm giving an example of Suzlon. This is the biggest company of India as far as wind turbine is concerned, and one of the latest companies globally also. Here you are saying wind turbine of 2.1 megawatt capacity. Now this turbine can be used at different heights. What about the output? You will get its output depending on the wind resource. At one site, you may get that desired output, desired wind resource at a height of 90 meters. So first case is like that. Rotor diameter is 111.8, same machine. Next case is where wind resource is comparatively less. That's why you have to go to the height of 120 meters. And then there you are getting the same 2.1 megawatt output at rated wind speed. And still another case is 140 meters you have to go up. The wind resource is comparatively poor. And you have to go to that height where wind speed increases further and you are getting the desired wind resource. So same can be used at 3 different heights depending upon the wind resource. And then another very, very important document for assessing, for estimating the generation, annual generation and all that, because that is the basic how much we will be generating. For that this power curve of wind turbine is required. And we are seeing here on the x-axis, that is wind speed. VC is cut-in speed, where it starts rotating and gradually then it starts developing.
Hello, sir. Uh, Avasti, sir. Sir, your voice is not coming, sir. Respected participants, I guess there might be some technical error. We are doing some necessary concern for it. Just wait for a while. We will start in a minute. Thank you.
Sure.
आपकी सर आपकी कौन सी स्लाइड थी सर आपकी कौन सी स्लाइड से चालू है कहाँ से बताना आपको चालू रखिए हाँ चालू आई होप द साउंड इज विजिबल हेलो
Yes,
Yes,
it
sir.
is
Yes,
visible
sir.
and sound is also coming, sir.
Yes, sir.
fine
Yes,
fine
sir.
fine okay so there was a technical glitch due to UPS sir please
Madam, can I continue?
sir you can please
Sir, yes, sir. You can continue, sir. PPT is
Huh.
visible, sir. You are audible
Okay.
also. Thank
Okay,
you.
okay. So these are some important parts of the wind turbine assembly, and you are seeing gearbox. We will discussing about this thing. This is one of the most problematic items of the wind turbine. Nacelle is the heaviest assembly that has to be lifted. So all these things will come in one way or the another. Blades, foundation, we will be discussing cover. What is there inside the nacelle? So all major assemblies you are seeing here. Even you are seeing the blades which are mounted on the hub, and these are the gearbox and generator and yaw motor. Yaw motor, we have to face all the this thing. You know, our these turbines, they are upstream side. All the time they are supposed to face the wind. So whenever there is change in wind direction, then after waiting for a few minutes, say 10 minutes, then there is a rotation in the wind turbine so that again it faces the wind. So this process goes on automatically. Just to give an idea, I have given here the cost breakup. It used to be 5.5 to 6.5 crores per megawatt on turnkey basis if we consider. However, now further very high turbines have also come up and coming up, still taller and taller turbines. So this cost will again go up, and now it is in the range of rupees 6.5 to 7 crore per megawatt. The cost depends on topology, distance from the highway, length of approach road, transport, foundation, distance. So many parameters are there. Some rough breakup is also given. 75% of the cost is wind electric generator. That includes turbine and all the equipment. Then civil works is 8%, foundation and approach road, office. Electrical installations, including that substation and extension for the grid, 12%, and land and miscellaneous. This breakup is given. O&M is very important. So it is 1.5 of the total cost. Plus there is a escalation of 5% because it will need more and more maintenance as it becomes older and older. Now, innovations. Very frequently we listen this proverb, necessity is the mother of intention. आवश्यकता ही आविष्कार की जननी है. These innovations and trends, they are necessity driven as per the need of the turbines and for better and improved performance. So these are some of the innovations and research directions. As I have told that wind and solar, these energies are variable in nature.
Sir, आइए. Ritu?
Sir, I guess ma'am is not here.
Okay, now is it visible?
No, sir. Slide is not visible.
Slide is not visible. Now it may be visible, I hope so.
No, sir, it's not visible, sir.
It is not, but it is showing me as sharing.
Sir, which account you are using, sir? Om Prakash Chauhan account you are using or Professor Awasthi account you are using, sir?
The same.
Same account, okay.
The same which was being continued. It is showing. It is showing. Now is it visible? Can you see it right now?
No, sir. I request Professor Om Prakash Chauhan, sir, kindly disable your sharing screen, sir.
Somebody has shared the screen.
Yes, sir. Om Prakash Chauhan, sir, have you shared your screen, sir?
Some participants have shared the screen. Sir, mobile से चलाया मैंने उसको.
Sir, now you can share your screen, sir.
Fine. Okay. So please tell these candidates not to share the screen. Otherwise, we will have a technical problem. That's why sir was not able to show his screen. Now it is visible.
Not now also, sir.
Microsoft is sharing your screen. It is showing me. Yes. PPT फिर. Okay, you give me.
Sir, kindly leave the meeting, then again join it, sir. Then might be you will be able to share the screen, sir. Once left the meeting and then again join, sir.
Now I have joined the meeting. Okay, and I am sharing the screen once again. It is showing me that the screen is shared. Can you see?
Yes, sir. Now it is shared, sir. Now you can switch on to the PPT. Now it's clearly visible. You are audible also, sir.
Fine, fine.
Thank you, sir.
Okay. Yes, sir. You can share. From which slide you were? आपकी slide पे थे?
ठीक है. मतलब शेयर हो रहा है ना?
हाँ, आप share.
Yes. So we have been saying that necessity is the mother of invention, innovations, because they are necessity driven, and they set the trends. On this sheet, I am briefly summarizing them, and then we will go for some details. We are all aware that wind resource is variable in nature. But for generation scheduling, we have to supply the generation schedule to the load dispatch center. How to do that? We don't know what will be the resource after 10 minutes or 1 hour or 6 hours or next day. Here comes the role of forecasting. So forecasting is one of the very important research areas as far as wind resource is concerned. This is not applicable for hydro or say coal-based or nuclear, all those things. But it is very much, this forecasting is very much applicable as far as wind resource is concerned. Another important area is foundation. We have seen that as we go up in the air, wind speed increases. That's why the trend has been to go higher and higher and higher. Higher towers, higher installing the turbine at as high as possible. But how long we will go like that? How long? So that is a concept of kite turbines flying. They are flying in the air. So in the tower, and once the tower is eliminated and its foundation, then things become simpler. But various other aspects are still challenging and yet to be resolved satisfactorily as far as wind turbines are concerned. But in so many countries, the work is going on. This is for onshore. It may be applied to offshore also. But what about offshore? Offshore, in the offshore means inside the sea. In the sea, we get best quality of uninterrupted wind supply. There is a constant flow of, it is much more generative. But as we go deeper and deeper into the sea, as we go deeper and deeper, so depth increases. Suppose we are going some 10 kilometers, 20, 50 kilometers, we will get better quality of wind, no doubt. But what about the foundation? We cannot go so much deep, say 500 meters or 300 meters and like that. It will become for installation. These special cranes required for installation. So they have to have a very high reach. For example, 100 meters is tower. 100 meters, you have to take very heavy load, say 150 tons or 250 tons like that, nacelle completely assembled. That has to be lifted and that has to be installed on the top of the tower. It is a very costly preposition. Secondly, you have to take all the way such a specialized crane from some remote place, maybe some 500 or 1,000 kilometers away. Such cranes may be available. You have to go to site. So approachable proper roads are required. And then where you are going to place this crane adjacent to tower, special foundation is required for crane also. A special platform is required so that it can be placed there. So it is also, so we will see whether there can be any, replacement for, if not fully, partly. So that also we will see. Next is gearbox. Gearbox is a very, very, very problematic. It is because one of the biggest nuisance as far as turbine industry is concerned. It gives a lot of problems, breaking of tooth and jamming, that so many problems are there, and which leads to many times breakdown, shutdown, and all that. Now, fire is uncontrollable. It is a big challenge, and there is practically no solution. But once it catches the fire, then your turbine is gone. You cannot do anything. Yes, we will discuss that. We may go for some mitigation measures or minimize the damages and all that. So we will discuss. Another is low wind regions. Let us talk about India. In only 9 states, only 9, we have installed all these turbines and making use of this great resource of energy. It is confined to only 9 states, and Kerala is hardly around maybe some 10 megawatt or so. What about other states? But if we go for low wind regions, and if suitable turbines are available, then there comes the role of vertical axis turbines. And there are already some innovations are going on, which will also be discussed. So these are some of the areas. Monitoring from distance. In India, it is not so much in practice, but in many other countries, European and other countries, we have heard of this unmanned powerhouses and all that. So from distance, from maybe 10 kilometers or 100 kilometers or maybe from anywhere you can see. So that is a monitoring aspect, which is again very important. Now let us start with tower foundation. And wind resource forecasting. Wind resource forecasting, it is a great potential area for research. What we do in forecasting, we estimate the futuristic. We should be able to predict after 10 minutes, 20 minutes, 30 minutes, 1 hour, 2 hours, what will be the wind speed at a particular site. How it is done? It is done on the basis of study and analysis and pattern, seeing the trend. It is a past trend of, it may be of years, 2 years, 3 years. As much data as you consider, your accuracy will increase, accuracy of forecasting. Here I have just shown you, there are so many approaches and methods are available. And one of my researchers, Dr. Rejo Rai, he has worked on this forecasting using statistical methods and applying artificial neural network. She has done this project, and nicely it was highly appreciated also. So there are so many methods are available. Now let us come to foundation. For foundation, I was initially mentioning that almost all the branches of engineering are involved. Here, how to start the foundation? You have to design. For designing, you will need a lot of mechanical inputs. You need what is the dead weight of the turbine. What are the cyclic loads? Cyclic, you should understand. It is rotating at different positions. The load patterns are changing continuously. Every moment it is changing. It may be normal wind. Loads are different. Wind speed is increasing. Going to cut off speed. Loading pattern is changing. You are applying the brakes. Again, loading pattern is changing. And can you imagine the kind of vibrations which are taking place in the tower 100 meters and above? It may be even half meter to 1 meter. Can you imagine? This kind of swings and vibrations, they are taking place. So all these things are, so all these inputs are required. Now you are seeing a picture of this turbine foundation. Soil testing. First, you have to see whether soil, how to design, what is the withstand capacity of the soil. The soil characteristics is something very important. I'm giving one example of a tower foundation of 2 megawatt turbine. Cement required is 3,400 bags. High grade cement is used. Steel required is 30 to 35 tons for reinforcement, and foundation to withstand fixed and variable cyclic loads. Okay, you can see, you can compare the people working there, and from their size you can imagine what is the huge. This is a huge task and very challenging and very important. What about offshore foundations? Now gradually you are seeing, first one is monopile, single pole you can go, and because it is very shallow, sea is very shallow, say up to 30 meters normally, you can go for this thing. But as you proceed further, when the depth increases from 25 to say 15 meters, then what we are seeing is jacket type of foundation. But when the depth increases further, greater than say 50 meters and above 120 meter and so on, And also the size of the turbine also increases because you get better wind resource as you go deeper and deeper into the away from the seashore. So what we are saying, there is a concept of floating foundation. And here I am showing this is the first floating foundation of the world in Norway. Siemens has supplied the machine. 2.3 megawatt, this is floating type. It is 10 kilometers away from the shore. And what is the depth? 220 meter. Please keep in mind 220 meters. A few years back, if I am correct, a wind farm has come up, 30 megawatt offshore, again floating, Scotland. 5 turbines of megawatt each on floating foundation. It is spread in an area of 4 square kilometer, and you are 25 kilometers away from the shore. Average wind speed there is 9.8 meters per second. And what about water depth? It is 95 to 120 meters. Catenary cables to keep it vertical, and all those arrangements are there. However, you will definitely find it interesting, and we'd like to explore it further. This is the view of that largest capacity wind farm as far as floating turbines are concerned. 5 turbines are there, 6 megawatt each. Generators, power electronic converters, and gearbox is related to that. Now we are knowing that historically we have been using induction generators. Subsequently, we went for dual speed induction generators to cover still larger range of wind resource, wind speeds. But breakthrough came when we went for doubly fed induction generators. Another type is synchronous. Synchronous generator. We know that synchronous generators are used in all our conventional power plant, whether it is thermal or nuclear or even hydro mostly. But another one has come up now. It has been existing in the past also, but permanent magnet synchronous generator, and how it has become possible, that we will see in the next slides. So with the development of permanent magnets, especially with long retentivity, its magnetism should not lose its magnetic strength with time. That is the requirement. So with all latest developments in the field of permanent magnets, all this has become possible. So what is frequency? Variable frequency converter for wind electric generator. Converters we all know, but it is for this particular application. So what does this converter do? So let us see. What is our requirement when we have to work in synchronism with the grid? Our requirement is that our generators, they should match with the grid voltage, grid frequency, and phase sequence. So phase sequence is once we have made proper connections, it is okay. So basically they are variable frequency and voltages. What are some conversion methods? They are mentioned here. And in order to maintain the all in these converters, what we do is the AC generated our output into DC, and then at desired voltage and frequency it is converted. So it makes the range of utilization of wind resource, a very wide range is given by this thing. In order to contain the harmonics, LCL filters are provided. Now you please just have a look. It is squirrel cage induction generators. There is gearbox is always there to get compact and economical generator. But in the second version, we are seeing it is given with converter also. wound rotor induction generator, and DFIG, dual fed induction generators. This is revolutionary, and it is highly used in various large megawatt range, all these turbines. What does it do? Power electronic interface of DFIG, it controls the rotor currents to achieve the variable speeds necessary for maximum energy capture in variable winds. Winds are variable, it just adjust accordingly. That is the great quality of this DFIG for high speed. And here also you are seeing the converter. Converter is connected to only rotor. So this is the beauty. It takes around 1/3 of the power. 1/3. The size of this thyristor and power electronic system, everything is reduced. Now, synchronous generators. Again, two types: conventional external excitation synchronous generator, EESG is mentioned there. And another is permanent magnet synchronous generator. It can be with gearbox to reduce the size, or it can be gearless. As we are going up and up in the rating of the turbines and generators, so it is a bit costly, but it has become very much affordable. And here comes the beauty, that once you go for a gearless one, you are getting rid of gearbox. So that's why for higher rating machines and systems, it is getting the higher and higher preference and priority. Which one? Permanent magnet synchronous generator. And here is the full power converter. I have shown this diagram here. You can see it is making everything clear. And next one is wind turbine with DFIG and back-to-back converter. Only 1/3 power is flowing through this thing. So size of all those electronics and everything that is substantially reduced. And we have decoupled practically this rotor and supply. Now we'll discuss about the innovations in cranes, and I have discussed also earlier. I have mentioned. We'll see whether towers can, to some extent or fully, do the job of cranes also. Is it possible? Let us see. These are different types of towers. First one is tubular. All these things are shipped to the site in segments. They are assembled at site. Another one, second one, you are seeing the lattice tower. Third one, you are seeing the hybrid. It is hybrid of lattice and tubular. And fourth one is also lattice. Now, towers and cranes. What is the present practice? Nacelle is totally assembled on ground. It is the heaviest assembly that has to be lifted by the crane. You can see this is how it is working, going on. The crane is lifting this heaviest assembly. Now next go to the innovation. As far as offshore is concerned, what is most desirable? In the sea, working becomes very difficult and very, very costly also, and also time consuming, and to some extent little bit unsafe also. So it is desirable that to the extent possible, this assembly should be done on shore. I mean, at the port. It is preferable. Whatever is possible, assemble it here, and that assembly should be assembled, taken into the sea and assembled there. So that has become the trend, and this practice is going on. It is a preferred practice. As far as offshore is concerned, why it is desirable? Lot of special vessels are required for transportation of materials, special materials, long material shaft, nacelle, transportation. For installation of turbine, another one equipped with heavy cranes and all that. Then for substation, another special vessels are required. And again for cable laying, special vessels are required, and some more special vessels are required. Now this is another interesting concept. What is done here? Transporting of men and material. What is done? Top of the nacelle, it is used as a helipad, and suppose this your site is 30 or 40 or 100 kilometers away, then how will you regularly send the maintenance staff, operation staff? How they will go? So it is one of the ways, and it is practiced also. And sometimes you have to replace some minor or large assembly and all such things. Then helicopter service is also used, and the top of the nacelle is used as a helipad. Now telescoping. In telescope, we see that there are cylindrical cylinders. You can adjust the length by taking out something and adjusting the required length. Similar concept is there. Conventionally, what we have been doing today, cranes are very costly, and reach of 100 meter and more, it is a problematic, lifting the heavy, long blades and heavy nacelles and hub and all those things. In telescoping, what is done? So let us see the view picture to understand. So this is the one. You are seeing the three views. So what is done here? This tower, it is in three parts, like telescope. We take out the inner one and prolong and prolong. So some arrangement is made inside by some compressed air or fluid or something like that. And what you do? The first one you are seeing, very small in height, 1/3 height. So you need a crane of very which has got a reach of very less, up to only 1/3 of the total height, and it will be very economical and all that. So this is how you are installing here. And then next stage is what? In the next stage, here one of the inner cylinders, it is coming up with the help of this compressed fluid system. And in the second stage, another remaining the tower section, it is coming up, and you are reaching the full height. Installation of wind turbine using lattice tower. In lattice tower, again, it is very interesting. You see, please, this figure. A, B, C, D, 4 stages are shown. In the first one, it is totally assembled, including the nacelle and blades, everything is assembled. In the second stage, you please see. In the B, first lifting a turbine. That point is coming to the ground, and it is a one part of the lifting. In the C, what you are saying, still another point that is, and this you can do with the help of chain pulley block or some other suitable arrangement. So something can be done. So in the C, you are seeing that still this topmost point, it is brought to the bottom by pulling or making some arrangement, and which can be seen that it is totally erected in the fourth section D. So this is how, in this case, you find that lift is totally avoided. Or very small capacity, for a short time, you will be needing the lift, the crane. So that is the advantage of this thing. So this is also, all these things are patented. This one is from USA, and it has been also patented. The work is going on, and normally it will be attempted for low capacity, these turbines with lower height. And then it will be, after its successful implementation, it will be extended to higher heights and all that. Self-installing floating telescope platform for deep water offshore. Here again, similar approach. You can see these are the self-installing. This is for floating. Floating means on offshore. Again, similar arrangement. Concentric cylindrical this thing are there. First one, second stage, third stage, as we have discussed earlier. So all these stages they are done. Now, what about the rotor blades? As the size of the turbine is increasing, the rotor blades they are becoming longer and longer and longer. Their transportation is again a very, very big problem and all. So, but people are still thinking of still bigger turbines and all that. So what is the way out? What is the solution? Because once they break, it becomes a nuisance. And such accidents are taking place also. What is the way out? First thing is transforming blade design and manufacturing. So this 3D printing and all these things have been, and profile of the blade is the very, very important. It is critically important because you have to. So in this case, what has been developed by USA, Swandian National Laboratories, with this they will be in a position to capture 12% more energy. So 3D printing concept, and this has been done by them also, jointly by M. Torres and Spain and Gamesa Corporation Spain. So this is the kind of machine. Profile is very important, everything. So a lot of research always goes on to improve the profile so that losses are minimized and overall efficiency is increased. And conversion from wind energy into electrical energy, that is finally increased. Now, something very important again. It is segmental blades. Blades are very, very long. Tower we have been using segmental in many parts and they are assembled. What about segmental blades? Is it possible? Yes. This concept is, people are working on this. Again, Sandia National Laboratories, USA. They are developing 100-meter long blades, which will form the basis, and that will be further increased to say 200 meters. About 2 times the length of the football ground. This is the concept coming up, and this will be applied for a 50 megawatt offshore wind turbine. 50, just think. As on date, maximum capacity installed is 12 megawatt. They are talking about 50 megawatt. But what about the blades? Very long blade, 200 meters. How to manage? If they will not break under severe, cyclonic conditions and all that. So what is the way out? What is the innovation that has been done? That you are seeing here. For capturing the full wind or maximum wind, it is totally open. The first figure we are seeing. But as the wind speed increases, they start bending. They start bending. And if the wind speed increases further, goes to cutoff speed or still higher and all that. So they are totally bent. It will work as a braking also. This is called aerodynamic braking. In normal conventional cases, what we are using today, these blades, they pitch in such a way that they align with the direction of the flow of the wind. They are not opposing the wind. So it works as a brake also, and machine starts after some rotations. That is called aerodynamic braking. This is also some different form of aerodynamic braking. So this is something very interesting. Let us see. It should come in near future. Segmental type of blades. Flying kite turbines. What is this? We have discussed. We are going higher and higher tower and higher tower. And how long we will go? So here is the solution lies in kite wind turbines. In this, generator may be flying or it may be on the ground. Accordingly, these cables are arranged. Here you are seeing the flying turbines. These are under experimental stage, and so many countries they are working on this. And they have partially succeeded also. But how to wind and unwind, and suddenly if wind pattern changes, and so there are so many still challenges are there. So let us see how soon such challenges are overcome. Again, helium-filled floating wind turbines. This is another concept, and it has been done successfully also up to 1,000 feet in the air and capture wind currents. This itself, it captures 5 to 8 times more than near to ground level. So this is the beauty of this thing. So this is helium-filled floating wind turbine. You are seeing the view of that. How huge is this one? In the bottom, we are seeing some arrangement they are making so that it can be fly. Like aeroplane, you have to run a little bit on a track. After that, it starts going up in the air. Some miscellaneous innovations which are going on. One is you will see very special design. This is ironless core they call it, but very little special and materials are used in this. It is a 10 megawatt and it is suitable for onshore, offshore both. This is the view you are showing. It is a totally different design. You have practically eliminated that huge size of hub and all that. And on this rotor, you are seeing the rim of the rotor in the center, what you are seeing. So there you see that is the generator. And blades are mounted in the A-shape supports. So this concept is also there, and it is for 10 megawatt, which has been successfully developed as far as design is concerned. So let us see when it materializes. Then torque splitting between 4 electric generators operated in parallel. In California-based wind turbine manufacturers, they improve the reliability in operation. They are providing 4 generators, 4 gearing arrangement. Gear gives a lot of nuisance and problems. So there are 4 independent cores. They operate in parallel. And what is the arrangement? If one of the generator or gearboxes they develop some problem, then other remaining ones, they continue to work. So it is not a total shutdown. It is only partial interruption in the supply, but machine continue to operate. So here is the photograph. You are seeing the 4 generator gears and gearing arrangement. Then this is a Japanese concept. They are working on this. This is typhoon turbine, typhoon, cyclonic, all these things. So this they are developing. It is working in storms. They say that, and we also know that there is tremendous amount of energy in the storms. And if they say, it is estimated that the energy stored in one typhoon could power the nation for 50 years. I don't know how it will be done because energy storage is a big challenge in itself. But this is the concept. And let us see how this concept, because when things are in the development stage, then they do not reveal so many details, which is natural. So this is the concept they are saying, and they are working on this typhoon turbine. Japanese are working. Wind hydro hybrid power plant. So this one, France and German companies, they are working. Wind solar plant, we have heard a lot. So many plants are installed in India also. But wind solar, both are variable in nature. But a very dependable one is hydro. It can supply constant power, no problem, absolutely no problem. And it is ready to supply power. Within, you can say, 2 minutes, it can go to full load and all that. So this is one of the best options as far as hybrid power plants are concerned. So wind hydro, they have, they are going for this thing. And now, what type of this hydro power plant is there? It is equipped with reversible pump turbines. What is reversible? So, in one direction of rotation, they act as generator and turbine as in conventional, generating the electrical power. But what about the reverse direction? When it is rotating in reverse direction, then it is pumping. So there is, in addition to the upper reservoir or dam, with the help of dam, there is a lower reservoir also. From the lower reservoir, it is pumping water to the upper reservoir. This is the job of the reversible pump generator. And when there is a requirement, it starts generating. So same set of machine which is operating as generator and turbine, in the reverse direction it starts operating as motor and pump. The wind energy in phase 1, they are going to install the wind turbines of capacity 13.6 megawatt, and in the phase 2 they will add 16 megawatt hydroelectric power plant. I could not check it. It must have been commissioned. It was to be commissioned some 2-3 years back. So I understand it must have been commissioned by now, but I could not check it. This is that photograph you are seeing. Blade is one of the biggest problems. So what happens if you remove the blade itself? And vortex, bladeless wind turbines. There are no blades. Into kinetic energy, which is then converted into electric. Aerodynamic effect called vorticity. It produces a pattern of spinning the vortices. We will see the figure. A vortex bladeless turbine cuts manufacturing cost by 53% and maintenance cost by as much as 80%. And in the figure, we can see that they are very tall and thin. So what is the advantage? In the same space, you can install large number of turbines. Compared to conventional turbines, you can install large number and from the same land area or something, you can generate much more energy. If you want to learn, then age is not any constraint. Even I did my PhD after retirement from Bharat Heavy Electricals Limited, from Manit, Maulana National Institute of Technology. But here is wonderful. Remained green. At the age of 89 years, he designed catching wind turbines in 2012. It is claimed that it compresses the air in order to create more power at the turbine. Blades are mounted behind the windstock, so there is no risk to the birds. This is one of the concern raised by the environmentalists and flying species. They are at no risk because of these blades are inside. And these turbines make virtually no noise. So these two are the major issues as far as wind turbines are concerned. It may harm, it may kill the birds, and it makes a lot of noise. So these two problems are overcome. And this design can be scaled up or scaled down for commercial power production or residential use. You can see this is how it looks like. Another one is hybrid turbine for calm wind. Again and again, same thing is coming. Wind is variable. Sometimes wind is not available. It is calm wind. What to do? How to manage? So most of the wind turbines can generate only 25 to 30% of the time. So here comes the role of hybrid turbines. In Colorado, means USA, they have developed one such system that they compress the air or fuel or something like that, And when there is, it will be stored. And what will happen if there is no wind? Compressed air will be moved upwards to turbo air motor. In that event, it will run the turbine without any
आइए सर. Yes.
Yes, so we are discussing when there is no wind. No wind means it is very low wind speed. What can be done? There is a way out. They are saying that they will be using compressed air. They will be operating the compressor by, say, biodiesel or maybe natural gas, something like that. And when there is no wind, this compressed air will be moved up to turbo air motor, which is coupled to the generator, and you will get the power. And at that time, as we do in the car, it will be automatically, clutches will be disconnected from the wind turbine and it will be operated by the pressurized air. And there are no emissions. Even if you use, emissions are very less if you are using for compressed air, natural gas or biodiesel, something like that. But anyway, this is a concept that how to take care of this variability in the wind resource. And this is that arrangement you are saying that all the things are mentioned here, how turbo air motor is there and all these things, and pitch controller, all these things are mentioned here. So communication and condition monitoring system. Communication is very important everywhere amongst us, as well as we have to talk with the machines. We have to know what is the condition, how is their health. So for all these things, communication and monitoring of their condition is very, very important. Now let us come to communication. Communication among the different domains of a wind farm. And here you should be able to see that this communication is wired as well as wireless. So from turbine domain, various sensors are installed. You are able to see this red color. They are the sensor nodes for wireless, this one. And blue color you are seeing, they are wired link, wireless as well as wire. They are coming to network domain, where you are seeing the base station. And finally, it is going to application domain. You are seeing the servers and SCADA system, all these things are available here. So this is how communication, so all the time with the help of sensors installed in various locations of the turbine, you are able to know the condition of your turbine, health of your turbine, generator and other important systems. Now condition monitoring system, CMS. What is this? Now here we are seeing a sectional cut view of the nacelle. So some examples are given in the main shaft bearing, gearbox bearing, power generator bearings. Although there are different sensors are there. Sensors are involved. From there, your data will be transmitted to server. Data management software is there. And then you travel further and you come to users. Your monitoring and analysis of software. Software are there. So this is how condition monitoring system arrangement you are able to see here. Now something very important which has come up, that is prognostic based condition monitoring system. What is this? An advanced indication or advanced warning of the future event or future failure. That's why it is very important, so that you can take the corrective action proactively. So this system is based on cloud digital modeling and intelligent software to simulate. You are simulating the real operating conditions for the wind turbine, important components. It helps in the prediction of the material, even up to microstructure level. If there is a micro crack or something like that, then you will be in a position to forecast. For example, if there is a very minor crack, how long this crack will take to develop and ultimately lead to the failure during the operation of the machine. If you continue to operate, it will take 10 days or 15 days or 1 month or 2 months. How long will it take? So that you can plan accordingly. And further other activities are also possible. Determine the return on investment, and so many features can be added. There is no problem in that. So this is one such area. This is some arrangement of prognostic based, and those who are interested in some particular areas, they should explore it further. All these informations are available. And as far as these innovations and all those things, in my book also I have covered, given a separate chapter on that. Book published by Terry. So all those things are, a dedicated chapter is there, in which all these innovations and research development and various research development laboratories all around the world, and all those things are given there. Now we are coming to uncontrolled fire. I have mentioned, once it catches fire, what will you do? You cannot approach some 50, 60, 70, 80, 90, 100 or even more. At that height is some catches fire, then what will happen? You cannot make any arrangement. And by the time you are able to make arrangement, everything is over, game is over. You cannot do anything. So this is one great research area. Can you think of something? It is burning. In one of the reports in 2000, so in 2015, there is a report that globally 50 turbines caught fire. Those turbines are gone. And in 90% cases, turbines fully damaged. It is very interesting to mention that once the turbine catches fire, no attempt is made to save it, because you cannot do, you are helpless. But what is done? It is done that adjacent turbines, they should not catch fire. So what to do? There are shrubs and grass and all those things on the ground. So what is done? They start cutting that, removing that as fast as possible, so that through on ground it does not spread and reaches to the other turbines. This is what is done. Spacing is adequate, 5D, 7D. So in the air it may not catch, there is hardly any chance. But through ground, so this is what is done, and this is it. So what I suggest, what I feel, can we minimize the damage? Can we do something? As far as fire protection, etc. is concerned, it catches fire from something. maybe due to lightning or something like that, or something happens in the oil or something in the inside the nacelle, lot of equipment, some is sparking. Any such thing may take place. So can we do something to minimize? One thing you please remember, there is firefighting arrangement, something is done. And you know, there are sensors also, smoke detectors. They will sense and leave, but can we use develop, or you can do some research work? Can you develop some special material, some such thing, so that they do not promote fire, or I mean, something can be done to minimize the damages. So this is one area which may be explored. What about low wind regions? Not only in India, everywhere. Large and very large regions are there. Large areas are there where wind is very small, wind resources are poor, very limited. So is it possible to explore these low wind regions? Yes, it is possible. People are working on that. Roughly, by and large, we know that vertical axis wind turbines are suitable. They are much better and can be used for low wind regions. But there are some innovative works which have been done and are being done. We will see that. Cell type wind turbines, they can run at very low speed. This concept has come so you can see that it is a self-starting type, and it can capture even up to 80% of the energy. And you can have a look at this. Its cost is also around 50%, it is claimed. This is the cell type of turbine. And I'm pleased to mention that one such turbine, I have been in the Rabindranath Tagore University, Bhopal. After pandemics, I resigned, but this thing was developed there also. I was totally associated in our this university itself. Total work was done, and we developed one such turbine, and it is functional. It is working. This is maglev, magnetic levitation. We are all aware. Magnetic levitation is used in the traction for trains. When there is no direct contact between the rails and the train, it is moving up in the air. When there is no such contact, then it is practically friction free. So work is going on, and it is expected that capacities from 400 kilowatt to 5 megawatt, means 5,000 kilowatt. Some such things China is working to my knowledge. Maybe some other countries are also working. So what is done? Ball bearings and all such things, they are removed, and what is done? Permanent magnets. And now we are getting very good quality permanent magnets, dependable, reliable, which retain for a long time their magnetic properties. So they are used. They oppose and keep it rotating quart rotor in the air. It is rotating in there, then you get much higher efficiency and all that. And this can start generation at around 1.5 meters per second wind speed. Is it not something great? What about horizontal axis wind turbines? This cut-in speed itself is generally not less than 3.5. 3, in some cases 3.5, even 4 meters per second. But here you start generation at even 1.5 meters per second. So how the blades are suspended and all that, so that we can see here. You can see here, these are applicable for vertical axis wind turbines. Air from any side. So that yeah mechanism that you apply to horizontal turbines to face the wind, and again you are rotating, sensing the wind direction and all that is not required. That is eliminated. It can capture the wind, let it be any direction. This is the beauty of the vertical axis wind turbines. There are no bearings, zero friction, cheap also. And it is Indian innovation as mentioned. Magnetic levitation based rotation. Beauty. Wind tunnel tower. Again, I don't know. They are claiming that it can generate even 600 times more than a conventional wind turbine. I don't know how it is possible, but this is claimed. You will see the figure and understand. Can you believe it can operate at as low wind speed as 1 mile per hour, 0.447 meter per second. This is the wind speed at which it can operate. It can generate 72% of the capacity at low cost of this thing mentioned here. There are no blades, no harm to wildlife. An Envolex wind turbine is shown. You can see here, this is the one. At the bottom, we are saying this is input. And as it goes inside and takes wider shape, I mean, it's due to Venturi effect, it is mentioned here. Due to Venturi effect, it picks up the speed and it starts rotation. So even at
Sir, I think hello, sir. Hello.
Practically available everywhere. 1 meter per second. You can get the generation. Wonderful. I've got a few ideas, and this idea I have not seen anywhere, but it has come to my mind. So I'm suggesting. And it has come this morning only. I was just going through something and it came to my mind. Do you remember this power curve which I showed you? In the power curve, when we reach the rated wind speed, that time we start getting the rated generator output. If the wind speed increases further, then there is no further increase in the output. Speed of this revolution of turbine, it is maintained same. How it is done? It is done with the help of pitching. Rotor blade angles are adjusted in such a way that, but what about still higher and higher and higher wind speed? They are all going waste. Can we think of something? Can we imagine something? Can we explore whether we can make use of that wind, that extra wind energy, which is above rated wind speed? If something can be done, is it possible? Needs to be explored. This is one idea which was coming to my mind. And one more which also came this morning in my mind. This horizontal and vertical axis. On this, one of my researchers from Bhilai, Chhattisgarh, Mr. Albert John Varghese, he has worked on this to some extent. I want to see that, how we decide the wind turbines and all that. It depends on the wind resource. When the wind resource is high, there is no problem. You will go for horizontal axis wind turbine. But what happens if the resource is low, it is poor, then you may opt for, you have to opt for vertical axis. But what is this transition? On a particular site, depending on the wind pattern and wind resource, can we optimize? On this particular site, this is the wind pattern and wind resource. Can we analyze it and see up to what range of wind speed, wind resource, it is techno-economically viable to go for horizontal or vertical, so that we can take most appropriate and correct proper decision. So these are some of the ideas which are coming to my mind. And as mentioned was yesterday also by Dr. Shalin Jain also. In fact, lot of work is going on and being pushed up even by government. You may recall that our Prime Minister also mentioned about hydrogen roadmap during his address to the nation from the Red Fort on 15th of August 2021. He mentioned this hydrogen road. We have to go for hydrogen economy. All these things. It is going to be one big area. What is the biggest challenge with that? That is the safety aspect. It is highly energy. Lot of energy is there. It should not explode or something. Accident should not face. So there is risk in its storage and transportation. These are the two major challenges. And it has got great potential for generation of energy, and so many industries, they need hydrogen. And for our vehicular traffic, this car and all those things, with the help of fuel cells. So this is one potential area of the hydrogen and energy storage, which also show the research direction for the future. These are the potential areas. And finally, before closing, I would like to mention that this is not the end with this lecture. Rather, this is the beginning. We are beginning. And if anyone is interested, may ask question right now, or may contact me. I have given my phone number also. They may contact me. I'll pleased to discuss anything if required. So I thank once again all the organizers to give me an opportunity to talk to you.
Yes, sir. Now you are live.
Questions आप ध्यान से सुनना, कई बार मेरे को समझ नहीं आता।
Hello, sir.
Thank you.
Hello.
Very much.
Hello.
Hello.
Hi, good morning, sir.
Very good morning.
Just a minute, participant. Just a minute, participant.
Yes, sir.
Thank you very much, Avasti sir. And now we are open for question hour session. Now you can ask your question, please.
Yes. Good morning, sir. Avasti, sir, your presentation was very good. You have given lot of ideas in our mind. You have made us to think really. So because a lot of things which we are not knowing, and what are the directions in which still research can be done in wind energy and wind turbines and all, you have explored, sir. So thank you very much, sir. And I am myself Dr. Anand Reddy, and I am working in KLE Institute of Technology of Karnataka State in Hubli. So recently I have worked on magnetically levitated micro wind turbines, sir. On one of, yes, sir, on one of the VGST, Vision Group for Science and Technology, which was initiated by our Rao sir, Bharat Ratna Rao sir. And yes, sir. So, and from that group, I have received some 5 lakh rupees as a project fund, and recently I have completed that. And what I want to ask you, sir, basically the challenges which I have faced in these micro wind turbines is, I have arranged those micro wind turbines in the form of a tree structure, and it was erected at the rooftop of our college building, where we have installed some 12 micro wind turbines of 100 watt capacity each, so 1.5 kilowatt for that. So the basic problem which we have faced is combining all these micro wind turbines output and feeding it to a battery. So the controllers for combining the output of all the micro wind turbines are not readily available. So some things we have made at in-house, and we have somehow coupled, and now we are feeding to the battery. So my question is, sir, how to whether this small size micro wind turbines are feasible for power generation, and if we want to develop, or if we want to harness the energy from micro wind turbines, what all the considerations has to be made, and the controller issue, sir. individual controllers are available, MPPT controllers are available, which you can feed the energy to the battery. But combining all that is a little bit difficult, sir.
Okay. First, I would like to express that I am feeling very happy that you are doing a wonderful job.
Thank you, sir.
The area what we have selected. And I would like to have much more interaction. So
Yes,
I have
sir.
already given my this contact number and
Yes,
email ID.
I have noted down, sir. Yes.
Because we will have to go in depth and properly understand, because your problem is not very simple. So I will have to properly understand it.
Yes, sir.
So that I give, because speaking just like that carries no meaning. I have to properly understand.
Yes, sir.
And then I will come out with what I feel about that. So I will be asking for some more details and all that.
Yes, sir.
And I will try to understand. If you are doing your PhD, then maybe your synopsis may help or something like that. So hope you will like to talk to me, and we will share, and I will contribute whatsoever is possible.
Yes, sir. And you have mentioned, sir, the wind velocity required for magnetically levitated is 1.5. Our turbines, sir, even cut-in wind velocity required for them is less than 1 meter per second, sir. They will start.
Maybe.
Yes, sir.
That
way, yeah, sir.
You are very correct.
Yes, sir.
It is very difficult to mention a single figure.
Yes, sir.
This work is going on in different countries.
Yes,
so
sir.
They are making different claims.
Really, it is very interesting, sir, because the cut-in wind velocity required is very less compared to the ball bearings.
That's why huge amount of you have to struggle a lot for locating where good wind resource is available. You have to struggle for years, and very limited sites are available. But low wind regions, it is everywhere. You can go anywhere in any agricultural field or any such thing. This much speed, wind speed will always be available.
So these wind turbines are very useful for urban area installation, sir. We are
Urban also,
concentrating. Yes, sir.
Long back, at least I should say around 15 years back, Chinese are installing on their highway also.
Yes, sir.
What they are installing, it is a hybrid, wind and solar. They are installing on their highways. So it is not something very, very new, but we have to see from our Indian environment, Indian conditions, and how it can be some workable solution, also cost effective. But when we develop something, we should not think of the cost.
Yes, sir. Yes, sir.
We should not think of the cost. If you manufacture new mobiles only, it will be very, very, very costly. But when we are manufacturing in crores and crores, they become just within the reach of a common person. What you are developing, it is wonderful. And we should not be very serious about the cost.
Yes, sir.
Thank
you, sir. Your presentation was very good, sir. Thank you, sir.
I am feeling happy that you enjoyed it.
Yes, sir. I enjoyed a lot, sir.
Yes.
Thank you, sir.
Any other questions of participants?
We are running behind the schedule.
No, sir. We have requested our next.
I will welcome the questions if there are any, or they may contact me later also, or they may put their questions, send their questions to these organizers also. So I will be pleased to entertain them.
I hope any participants is having another question. Okay. So I presume that there are no questions. So I would like to thank Professor Awasthi. I would like to share some special thing about him. When he came to deliver the lecture, he collected some waste plastic bottles that were lying on the road in his car, and then it is his habit, wherever he goes, wherever he sees plastic, he collects those bottles and puts them in dustbin. And he is a true person of green energy. He practices by his acts. This is the best part of Professor Awasthi, and you will be surprised to know that he has done all his research and everything after his job. So let us see the energy and the positiveness he is having at this age of learning. And he has written very wonderful books on renewable energy. If possible, we will share some of the slides with you. So thanks again, Dr. Awasthi, for delivering such a wonderful lecture. Sir is showing his book, which is written in collaboration with Terry. I think that they are very wonderful books. And he is very open for, you can say, suggestions. He used to help people. If you have any doubts or any queries, then you can contact him and he may try to help you on your issues of wind energy. So thank you for patiently listening. Thank you, Awasthi Saab, for giving us time for your valuable lecture. Thanks again, sir. I thank you on behalf of Electrical Engineering Department and organizing committees.
Thank you, sir.
Our next session will start 30 minutes late. That means the scheduled time था उससे आधा घंटे बाद शुरू होंगे and it will be the lecture of Professor D.P. Kothari. So please join at that time. Thank you. And you can share the feedback and attendance of this session through the Google form which has been shared to you through the chat. Thank you, sir.
Okay. हमारा डर सही निकला, हमको घर में कुछ करेंगे तो बंद कर मुझे बोला ना बिल्कुल